She tried to ping you as well. Actually.
Hi, welcome back
Oh,
to the
yeah,
third virtual national CIO conclave. And now we are quickly moving on to our next interesting technology presentation on future ready architecture for hybrid cloud. And would like to welcome Sam Kaitan, Director of Business Development, PCA and ODA Oracle, to do the presentation. So over to you, Mr. Sam Tan.
Hello, everybody, and thank you for joining me on today's session. I would like to thank the organizers of the third National CIO Virtual Conclave for inviting Oracle to this session, and I'm very pleased to be able to be here to talk about Oracle's Private Cloud Appliance X9, a platform for a future-ready architecture for hybrid cloud. For those of you who don't know me, my name is Sam Chan. I'm the Director for Business Development for Oracle Systems. I cover all of Japan and Asia Pacific, and unfortunately, I'm unable to be there in person to present this to you live. However, I am pleased that I'm able to do this via the marvel of technology. As you can see from the slide here, I'm based out of Sydney, Australia, and I promise not to talk about cricket. Instead, I do want to talk about something that everybody has been talking about for the past few years, and that is cloud. What is so great about cloud? If you ask different people, you'll get different answers, but it usually revolves around one of these key areas. Some customers see cloud as a way to become more agile, the ability to adapt to changes, to respond quicker to customers and to market demands. Some other people see cloud as a way to get faster time to market, to be able to roll out new services and new products to their customers quicker than before. Another view of customers is scalability, the ability to achieve massive scale if demand increases, if business booms, if success is overwhelming. There are also some that see cloud as a way to achieve platform independence by not being tied into a particular brand or particular architecture. And last but not least, some customers see cloud as a way to achieve security, to have a team that is able to have experts on how to implement a secure, robust, reliable platform for them. Whatever it is, customers see different things, but they want it. They want this cloud architecture for their own data center. That being said, public cloud usage is only a fraction of total IT spend. In 2021, Gartner estimated that only 17% of total IT spend was on public cloud usage. Put it another way, for every dollar of IT budget, less than 20 cents goes to public cloud, which means that 80 cents out of every dollar is still spent on on-premises investments, be it networking, be it servers, be it storage, be it infrastructure to power data centers, cooling. It's still spent on premises. Even by 2026, it is only going to rise to 45%, which means that more than half of IT spend, even after the middle of this decade, will still be on premises. Only 45% will go to public cloud. Why is that? Why are so many people finding it hard to go to cloud if it's such a great offering? Let me venture a couple of theories. One of the biggest challenges I think that one of the biggest challenges I think that customers face in moving to cloud is a migration of the current processes. The evolution of, for example, DevOps, the classical method of releasing new services and new software into a data center on premises, but adding in the extra weight of having a cloud. So if you look at this diagram here, you can see that how operations and development are like two cogs in the wheel, and they work together to achieve an outcome. Once you add in a third cog into the wheel, nothing moves. Everything just gets stalled, right? And the engineers in you will recognize this, that this is what's happening here. So how do we get around this? How do we fix the problem to enable customers to take advantage of cloud in a quicker way, in a more seamless way, in a more efficient manner? There are no straight solutions. There are no easy answers. There's no silver bullet. But I want to talk about two open source projects that Oracle is working on that you may have heard of before. They are specifically Graal and Verrazzano. And I'm going to talk about both of this and how they solve two very specific problems. And if you have these issues, then perhaps these might help you in your cloud journey. Let's talk a little bit about the development wheel, right? The one half of DevOps. Development has evolved a lot over the last 50 or 60 years. If you look at how computing science students were taught to do development, even as recently as 20 years ago or even 10 years ago, some of the techniques that are used for software development today are completely new. A lot of them are less than five years old. And it's constantly evolving. And part of the evolution comes from the different ways that software is being written. In the olden days, you write a piece of software, you compile it down into a binary, and you execute the binary. Today, a lot of code now is done in one or two ways. You either download something from the internet, something that's already been pre-written, something that's a library that's available to you, or you write at a high-level language, for example, like Python, and that gets compiled down into some intermediate representation that then gets run by a runtime. So the fact that you're not writing directly to the hardware, the fact that you're not writing down to the OS level anymore, changes the way people think about software development. There's a lot more steps in that development pipeline now. The downside to some of this is that you now have a lot more technology to worry about. You have a lot more projects to worry about. Why write a new web server when there's a perfectly functional web server available for you to download? Why go and download a queue management system when you can download one from the internet? Why go and write your own management and monitoring tool when there's a perfectly good one for you to download? The problem is that there are so many to download from, right? If you just look at this list, this is just a list of cloud native projects as tracked by the CNCF, the Cloud Native Computing Foundation, that are available for cloud native services. You can see that in every category of component, every category of modules, there are dozens, if not hundreds, of open source projects to choose from. The problem is that you might choose the wrong one. What if you choose a project that meets your needs today, but over a couple of years no longer goes in that same direction? It decides to take a different tack. Or what if that project, for example, is no longer being maintained because the project maintainer has moved on to something different? All right. Two examples of this is a lot of customers out there have gone and deployed CentOS, which is the open source version of Red Hat Enterprise Linux. And what's happened is that Red Hat has killed off CentOS. You no longer have a CentOS option to download, and now customers are scrambling to figure out what are the alternatives. Okay. Another example at the extreme opposite end is a project called RiserFS. So RiserFS is a file system written for the Linux kernel. It's been in the Linux kernel now for at least 10 years, but it hasn't been developed over the last 5 or 6 years because the project maintainer apparently has been spending time in federal prison. Okay, and obviously you don't get access to computers and IT when you're inside there. So the challenge for a lot of customers is, how do I pick a project that will suit me long term? That's one of the challenges in using a lot of these open source technologies. The other side of this issue is that a lot of these open source technologies are written in many different languages. It happens to be the language of choice when the project maintainer decided to develop that software. So sometimes it's written in JavaScript, some of it's written in Python, some of it is written in Java, and then there are those that are written in the brand new languages of the season, right? There's Go and Kotlin and Rust. How do you maintain such a wide range of software programming skills? How do you maintain such a wide range of skills in your data center team? This is an analysis of programming skills based on a survey done by Statistica. Most of you will notice that they don't add up to 100%. In fact, they add to somewhere around about 400 over percent. What this says is that the average programmer out there needs to know 3 to 4, if not more languages just to do their job. The average systems administrator, data center administrator, programmer, developer, application developer needs 4 or 5 of these skills to be able to work on their projects. That's the kind of world that we're living in today. You cannot do everything in one language. Even if you were able to find these skills, even if you were able to find people with this ability, what's the downside from a technology perspective? The downside from a technology perspective is, as I said before, every single one of these environments requires a runtime. If you write Java code, you need a Java VM. If you write Python scripts, you need a Python interpreter. If you write JavaScript, you need an engine like the V8 engine to run it on, and so on and so forth. And every single one of these runtimes is an extra layer you have to maintain. It's an extra module you have to patch. It's an extra component that you have to secure against malware and attacks. It basically just opens up even more of your attack surface for people to get into your environment. More so if you don't have the skills in maintaining and managing it properly. Is this really a concern? Is this really an issue? Yes, it is. This is a list of all of the recent software supply chain attacks. What's a supply chain attack? A supply chain attack is an attack at the source code level or at your libraries level. Hackers now don't attack you directly. They attack the libraries that you use. Key example of this was SolarWinds. SolarWinds is a IT management company. They sell software for customers to use to monitor and maintain and manage their networks. Hackers infiltrated their source code system, injected source code into the SolarWinds development tree, and when SolarWinds compiled it and released it as a patch, every customer that was a SolarWinds customer, including some government security organizations, when they patched their SolarWinds Orion software, they downloaded the malware with that patch. Okay, and that compromised all of the internal networking, compromised the exchange servers, compromised the email communication. Okay, so going back a slide, if you think about all those projects that are available in the open source world, how many of them do you know do not have malware, do not have some kind of code injection inside it that you did not accidentally insert into your own projects? And the only way you can be sure, because it's open source, the only way you can be sure is for you to actually do that vetting and do that scanning. And that's a lot of work. It's not an easy task. So what's the solution? Well, you can't stop using open source software. You can't stop using other people's code. You can't stop writing code because you have to develop. So let's talk about how to reduce your attack vector, reduce the attack surfaces that malwares and foreign threat actors will try. That brings us to Oracle's first secret source project called GraalVM. So what is GraalVM? At its very basic level, GraalVM is a Java VM. It runs Java code. So if you write code in Java and you compile it into the bytecode, GraalVM will run Java. And just like any Java VM, GraalVM runs on multiple platforms. So you run it on Mac OS, you run it on Linux, you run it on Windows. That means that you can write once and you can run anywhere. That sounds like a standard Java VM. So what's so special about GraalVM? GraalVM supports other languages as well. So if you write JavaScript, if you write Python, if you write Ruby, all right, if you write R code, you can run that code on GraalVM as well. So this reduces the surface attack surface for your environment because you only have to maintain one runtime. You only maintain one layer that your code runs on. You patch one layer, you secure one layer, you optimize one layer. Is this the only way to do it? No. Some customers may choose to go and standardize on the Python runtime engine. Some people may choose to standardize on the JavaScript runtime engine. There are many options. But GraalVM is the one that Oracle supports because it runs and natively supports the most popular enterprise development application today, Java. There is more Java enterprise code running in data centers across the world than any other language at the moment, which is why it makes sense to pick a Java VM and then put other language support on top of it. So this is Graal. It's an open source project. You can go and Google for it and download the code and you can run it yourself. I think we're at version like 18 or 19 at the moment. So it's been around for a while. Okay. So we've talked about the development side. Now let's talk about the operations side. Over the last 20 or 30 years, there has been a lot of changes in the way software and hardware are being utilized in data centers. A long time ago, there used to be dedicated hardware. So customers would have a data center and they could easily point to, this is my web server, this is my app server, this is my database server, because every server ran only one application. Over time, because of Moore's law, the number of cores, the amount of compute, the amount of performance per server increased rapidly. And it grew to the point where each server started to become oversized for its purpose. So in order to do a more efficient usage of the hardware, hypervisors came about, right? The most popular ones being things like VMware, KVM, Oracle VM, Hyper-V, and many, many others over the years. The idea behind a hypervisor is it takes a physical server and it creates virtual server. It was great for what it did. It was great for a data center, but in reality, it doesn't work very well in a cloud world, right? Because as you can see from the diagram in the middle, it requires 2 layers of operating system, which means that you actually have to maintain that operating system as well. You have to patch it, monitor it, you have to secure it. Most cloud vendors out there writing cloud native software are looking at container technology. And container technology is the same idea of virtualizing hardware to have multiple smaller virtual servers, but without the added overhead of an extra operating system. And container technology is actually very, very popular. How do I know this? Because according to Statistica again, over 80% of customers are looking at containers, right? 20% of them say that it is a strategic strategy for them today, and there's about another 30 or 40% that say that we're going to be using it within the next 18 months. Okay, there's only 11% that currently say that containerization will never play a strategic role in their organization. And the URL's at the bottom there, so if you want to click on it and go look at the link and read the report, you can do that. But regardless of what you find, you have to think for yourself. Do I want to use containers, and do I need to use containers, and how would I use containers? Once you get to containers, you get the ability to actually be able to use a lot of cloud technologies. You'll be able to deploy in the cloud in a quicker, more seamless, and more efficient manner. What's the downside, right? Nothing comes for free. So if you get containers and it solves all of your deployment problems, what's the downside? The downside is that now you are able to deploy on potentially thousands of servers, maybe even tens of thousands of servers. You're able to, with a single click of a button, say, deploy my web application on all of these machines across my data center, right? And it will deploy all. How well will your software work? And more importantly, how will you manage it? And even more importantly, if there's any problems, if there's any attacks, if there's any exploits, how do you detect it and how do you track it? So the complexities of scale are that it's quite possible for people to manage, let's say generously, 50 servers for each data center administrator. That works great on a personal, private, corporate data center. It doesn't work in the cloud. Google is known to have somewhere in the order of 30 to 35,000 servers in each of your data centers, right? Oracle is probably around the same kind of range as well. So you can tell that the ability to scale becomes much, much more important than just adding people. I don't need to tell you that, yes, there's a lot of people in India, but you're not going to be able to hire enough people to be able to manage data centers at cloud scale. The other side of the problem is one of distance. Everybody knows that light travels at a finite speed. Nothing travels faster than light. And data centers use fiber optic cables with light traveling down those wires. You cannot get any faster than the speed of light. If you move something to twice the distance, it will take twice as long. And with consolidation and with aggregation of services in large data centers in key locations around the world, that issue starts to become really serious. You might deploy today on a data center located right there in your hometown, in your major city, and your latency is great, your performance is fantastic, your response time is off the charts. What happens if there's an outage? If there's an outage, that service fails over from that data center in your city to potentially a data center around the world. What's the latency for that? What's the response time for that? How will this impact your business? Can your applications even handle it? So this is something that needs to be thought about, even if you don't ever think that you're going to be using something in a remote location, because it just might. Your data center provider, your cloud provider might do a failover. They may have a scheduled maintenance. They may have a scheduled outage or something. The next thing that's a problem is that it's not just about cloud. A lot of customers cannot go to cloud because of legal requirements, because of data sovereignty issues, or because of risk management, right? Where there's a risk issue involved in putting your own corporate data into a cloud provider. So a lot of customers are also looking at doing hybrid cloud, where they have some parts of the data center in private cloud and some parts of the data center in the public cloud. And then they have something in between where a service can actually be distributed across both public and private. How do you manage this? How are you going to manage an environment that is made up of stuff that you have classically done on premises in your data center, stuff that is brand new, state-of-the-art, bleeding-edge public cloud services, and try and find a way to manage it all from a single view in between the two of them? So this is the next part of Oracle's secret sauce. Oracle has another project, another open source project called Verrazzano. And Verrazzano is an enterprise container platform. It is a container platform that allows customers to manage private cloud, public cloud, and all the stuff in between. And it's built on the Kubernetes engine, and it will run your traditional applications, your classical Java microservices, enterprise Java Beans, Java EE services, as well as the latest state-of-the-art polyglot microservices using Python, Node.js, or even Ruby. And obviously, if you put Graal on all of these platforms, you can run all of your different services on a single runtime. So Verrazzano and Graal gives you a simplified, unified view of having to do your enterprise both in the public and private cloud and in between, and to reduce the development overheads of having disparate, complex runtimes. So let's put it all together now. What is the future-ready architecture for hybrid cloud? The Oracle way. First of all, we believe that having a unified, simplified runtime and a unified enterprise container platform is essential. You don't want to have multiple deployment engines. You don't want to have multiple runtimes. You don't want to have incompatible data sets. You don't want to have issues transferring data between different libraries. So unifying all of the underlying infrastructure is key. Oracle's two projects, GraalVM and Verrazzano, are designed to address these needs. It may work out, it may not, but at least we're trying to solve the problem. So what does this mean? Does this mean that you have to go and download, install, and compile and build Graal and Verrazzano? You could absolutely do it yourself. Instead, you could run it on an engineered system. So this is where we come in with Oracle Private Cloud Appliance. Oracle's Private Cloud Appliance is an engineered system that is integrated with Oracle Linux Cloud Native environment. It is designed to run all of your classical workloads using technologies like Oracle VM or KVM, Ansible, Terraform, Kubernetes. It runs all of the containers like Cryo and Docker and Kata and Runc. Okay, it is available on premises, in the cloud, as well as the in-between cloud, which is the Oracle Private Cloud at Customer. It has a single management view using Oracle Enterprise Manager. All of these products are available today. They are being used by customers today. It is in production today around the world. What does it mean for the future? In future, you can also run the new stack. You can also run the Verrazzano Graal stack on top of the PCA. They coexist, they cohabitate, and they can happily work together right next to each other. This means that with the PCA, you are able to run your existing environment port it over onto a more modern platform, and be ready for the future in whatever direction that you may want to go, because that's Oracle's vision for this. So in summary, Oracle's future-ready architecture meets 4 requirements. It supports your current contemporary architectures as well as your future architectures, whatever they may be. It supports your traditional deployment, which is your traditional way of writing code, traditional way of rolling out and deploying, doing your DevOps, as well as the new cutting-edge cloud-native development technologies involving new features and new capabilities and new modules. It is a single stack across our engineered systems and Oracle Cloud. So the Oracle PCA and the OCI, Oracle Cloud Infrastructure, have the same APIs. Whatever tools you use to deploy onto Oracle's PCA are the same tools that you will use to deploy onto Oracle's OCI Cloud. And the essence of our Oracle Engineered Systems message, it is hardware and software integrated to work together. When we ship you that PCA, it arrives in a rack, ready to go, plug it in, turn it on, and be productive. And it is ready for your workloads for today, for tomorrow, and for the future. I thank you for your attention. I hope you found that useful. Please feel free to connect with me on LinkedIn, and wherever you are, please stay safe, stay healthy. Thank you, everybody. Namaste.
Thank you, Mr. Sam Tan, for such a great technology presentation. And as a token of appreciation, Elets would like to present a certificate to you. Can we have the certificate on the screen, please? Yeah. Thank you, Mr. Sam Tan, Director of Business Development, PCA and ODA, Oracle. Thank you.